Hello, this is a computer organization and operating system class. Here in this, this is a 12 slide. That is the last slide for learning in this class. Today we will talk about the file input output management in the computer system. After your study, you can recognize the type of the buffer, and also you can explain the characteristics of data access in the hard drive. In the example, this is the first in first out data access in the hard drive. After that, you will understand the RAID or RAID, that is hard drive management in the computer system. Finally, you will understand the disk cache, that is buffer or data transferring between the hard drive to the computer system. Here this is the topic for study. We have four topics: buffers, data access in hard drives, and disk cache. Now we will move to the detail of the buffers. Uh, the buffer, What is the buffer? The buffer is a temporal memory. Temporal memory. Look at this picture. A buffer is a list box here. By the buffer have a function about the keeping the data before transferring to the another, that is buffer. Buffer is between the I/O, keyboard, mouse network, and to the memory, motherboard, and operating system. That means the buffer is a storage. This is a very small storage. When you are type the keyboard, the data when you are type from the keyboard will keep on the buffer, and then the motherboard by operating system will get the data from the buffer to processing. Here, this buffer we call the hardware buffer. The hardware buffer. Most of the words of the buffer that mean the hardware buffer. Sometimes another call the I/O buffer. This is the same meaning for the hardware buffer. You can implement the buffer by use the software. You can write the code to manage the buffer. You can write the code to do the buffer and doing the function like as the buffer. That I will tell you the next slide. For the software buffer, that is the operating system or the application manage the memory to read or write the data as functions of a buffer. So here this is a hardware buffer, and also inside the operating system, maybe it have a buffer, and also you can implement buffer inform the software inside your application. Here in this picture, I show no buffering system by the data sent from the I/O, example from the keyboard. When you paste a keyboard, the data from keyboard sent directly to the operating system, bypass the hardware, example motherboard and I/O device, passing directly to the operating system to your application. This is no buffering system. In the no buffering system, if you write the code in this example, here in this code, I I keep the keep the data hello world to the variable x, and I send the data directly to the uh, variable data and pin on the screen, and then moving back to the main program. Here in this is example for writing the code without the buffer. Now you can make a buffer. The very small buffer that have a system have a buffer here. In this picture, we have a buffer by we call the single buffer. Example, I type a keyboard. I type the keyboard and send the data for write to the buffer. Example, I type the A button, the A, and then the application software will get the data A to do the process inside the application. Here in the example like this, I make a variable buffer here. The variable buffer will will like as the temporal memory for keeping the data from X to the buffer, and then it send the data to the function here to process in the program. That means you can write the hardware buffer and also software buffer doing as a single buffer. The next that is in this we show you I show you the buffer double buffer double buffer. By the double buffer concept, inside the hardware or the software have a two location of the buffer. Here in this is first buffer and here in this the second buffer. In the buffer have a mechanism for read and writing by it have two pointer or two indexer. Two pointer by here in this is right pointer, right pointer, right pointer, right pointer writing the data from the I/O device to the buffer, and read pointer read the data from the I/O device, read data from the buffer and send to the application program or to the next hardware. Here in this have a write pointer and read pointer. Maybe sometimes it's called write index and read index. And when here in this, when I type the keyboard, I type the A here. The A data will write to the first buffer. And in this, the second buffer have unknown data. The unknown data will send by reading to the process. And after that, when I change the when I read the data complete, the pointer will change from here to here. Sorry, and pointer will changing from here to here, and also the pointer from the reader move to here in this by switch and then I type the letter B from the keyboard, the letter B right in here, and then the letter A read to pin at the process in the output. In this In this, I show you how to implement the double buffer by writing the C language. In this code, look at the if condition. The if condition will check index right. If index right is 1, the index right will change to 0 and index least change to 1. And if index right is that is not 1, is change is index y is 1 and index list is 0. At this is a swap like as moving in the in the pointer in the double buffer. You can implement the buffer over the double buffer by doing like this. And here this is we call circular buffering. Before we go to the detail, the circular buffering, I show you all the code from here. I developed to show you the double buffer. You can write this code in the online GDB, online GDB, online, no, online GDB website by writing this code writing in the C++ language. And after you are run in this code, this is the output for after you are running. By the program make integer buffer. By the integer buffer setting the start location of the index lead and index right, and also set the empty buffer by I set the -1 to be the empty buffer. And where is the location of the buffer here? In this is the buffer variable for keeping the data, the buffer. And here this is a double buffer management code. And in this is a pointer, index list, and index line. You can implement by modify this code to do the function like as the circular bufferings. Here in this is circular bufferings. The circular buffering have a more buffer location and use the technique read and write same as the double buffer, but changed by the changing addition number of the buffer from 2 to 15. In here we have a 0 to 15 that we have a 16 location for the buffer. Circular buffering implement like as the circle of the memory. Here in this, the lead pointer point at location number 2 and the right pointer point at the location number 6. Here in this, that means when you read, you get the data from this location out, and when you write the data will write in this location, right to the memory. And in the mechanism of the circular bufferings have two pointer, read pointer and write pointer here. That means when you type any text in this, the data from text will keep to this by the buffer, circular buffer, and the output from the operating system will get and send it to the user process The circular buffering used in the some hardware that have a different speed for reading and writing. Example here, in this hardware, write and stop and write and stop, not continue as reading writing. But here in this device, read the data quickly. So the different speed from in and out, you can make in this concept. But some problem when the outside reading slowly, but in the inside writing very quickly. Maybe this is will occur the buffer full. So you should implement by the outside by lead side should reading the high speed over the writing by the inside to protect the buffer overflow occurrence. Here in this is circular buffering. Circular buffering have implement inside the keyboard, mouse, and when you send the data from your computer to the printer, you send the data to the internet to a lot of application in the computer system use the circular buffering. Here we will talk about the next topic about the data access in the hard drive. Now we will look at the hard drive. When you buy a hard drive or hard disk, you don't know about inside the hard drive. In the market, we have when you go to the computer shop to buy a hard disk, the the seller will ask you type of the hard disk that you install in the system. They, maybe they suggest this is hard disk for the NAS network access system, or the server. Here in this hard disk for the CCTV camera system. Here in this has this writing in very high speed, reading in very high speed. That is a different type of the hard disk. Inside the hard disk, not only the durable and data access for specific the function specific in characteristic in the hard disk that have the algorithm for moving the head of the hard disk. But here in this is the inside the hard disk. The hard disk inside have a magnetic paste, and this is a head of the hard disk. When the hard disk read or writing the data, the head will move in and out, move in and out. Moving of the hard disk is moved very quickly, and also the transferring speed is depend on the moving or that we call towerings from the hard disk. By the towerings of the head in the hard disk that we can implement in four algorithms. By the first algorithm FIFO. What is the FIFO? FIFO is the first in, first out, first in, first out. And the second SSTF, that is abbreviation from shortest service time first. Shortest service time first. And technique of the scan and circular scanning. Now we will look at the in each type on the hard disk. Here, I suppose I have a sequence of the data from the location on the at the hard disk. Before we go to the detail, I suppose here in this location, where is the location 55? In the hard disk divided in the circular and sector. Circular and sector. Here in this. And in this hard drive divided by partitioning in the circular and sector. Here in the sector 1, in the sector 2, I suppose 55 is a location. Example here, in this location 55 in the hard drive, and 100 184 is maybe the outside 184 in the hard drive or hard disk. Okay, now I suppose I send the location from the data to the algorithm, to each algorithm, first in, first out, shortest service time first, scan and c-scan. And I compare the speed from each each algorithm. Now we will look at the detail of the first out algorithms. From here, this is a table for comparison access speed by here in this is first in first out, shortest service time first, scan and C-scan. By the comparison is made by the start location of the hard disk of the head of the head hard disk at the location 100. The start location. Start location. Start at the same location at the 100. Now, first in, first out, that is the first job come, the first job out, the first, after the first job come to the list, and the process of the first job will be the process first. So that means in this is the sequence of the track, sequence of the track. By here in this is a sequence of the data, sequence of the data start from the 55, 58, 39, 18 until to 184. Okay, here from the location 100, move to the 55, the the head of the hard drive will move from the 100 to 55 that's past 45 45 track 45 tracks 45 that's come from when you are being the 100 and minus with the 55 it will be 45. And the next step, the head of the hard drive from the location 45 is moved to the location the 50x that's past 3. That's past 3. Oh no, sorry. I told you wrong. Here in this, after that, the head of the hard drive from the location 55 is moved to the 50x. Is moved to the 50x. Is past 3. Is past 3 here. And then the location 58 is moved to the hard disk moved to the 39 is past 19 tracks and then is moved from the 39 to the 18 is part 21. Now I sum from the tracks passing in the hard disk then and calculate in the average value by sum and divided by number of the location of the data 1 2 3 4 5 6 7 8 9 and division by 9 it will be 55.3 average 6 glance. Here in this is first in first out and the next techniques that we call shortest service time first. Shortest service time first that have a mechanism that's mechanism to ordering the data access by the sequence of the access from the hard disk start at the location 100. From the location 100, that's that is a cost from the location 100 that is 90. When you look at this, which location that's close to 100? Which one is close to 100? Is it maybe 90, 90. And over 100, where is over 100? I think it is 150. That is not close. That means only 90 that's close to 100. So here the heads will move from 100 to the 90 and have only 10 tag pass. And then from the 90 the algorithm will check from the 90 where is the cost to the 90. Cost to the 90 is maybe from here is maybe 50 50x. Is maybe 50x is moved to the 50x. Is past 32 track, and then the head will check from the 50x where is its cost 55, from the 55 where is cost 39 until to end. Here in X10 is no location for cost. It's moving back to the location from the here in this code to the 100, that is 150. So after that it's moved to 180 and then moving up from 150 to 160 and moving up from 160 to 184. Then after that, you calculate average number of passing tags. It is average at 27.5. So here some hard disk that's leading very high speed implement by use in these algorithms. And some hard disk may be implemented by first in first out. Now, before we go to the detail of the scan and C-scan, I will talk about the type of the hard disk in the CCTV. For the CCTV, when you buy the hard disk for CCTV, the CCTV, the first, very important condition when you buy a CCTV hard disk, that is durable. That means this hard disk not running quickly, but this hard disk we need the durable function by using to the very long time for very long time, 3 year, 4 year, or 5 year. So here in this hard disk will design by make reduce the number of head of the hard drive movement by movement very slowly and movement number of the moving up and down in reduced number moving up and down for scanning the data. So the implementation will check the direction from the data by increasing or decreasing. Here in this, the location start at 100, and the hard drive, the direction of reading now is increasing track. That means we're moving from 100 up to 101 until the maximum value. So here from direction increasing 100, so the head of the hard drive will move from 100 to 150, and now from the 150 at the location that is code for 150, this is 160, so it's moved to 160 and move to the 184 until here. In this, This is the maximum location, and the high end of the hard drive will moving back, moving back. By moving back from past to the 100 and past to the 90, 90, 58, 55 until to 18. Summary, average 6 is 27.8. It is over the shortest time first, but it can reduce the number of head of the hard disk. For here from the SSTF and ScanS, then in this output that not show you the reducing number of the movement, but when you compare a long data, very long data, the scan will display the number of the hard disk movement. It is maybe reduced over the shortest service time first. The fourth that is C scan, and here in this I show you the first in first out, the first in first out. Here in this picture, in this picture, it is a part of the hard drive movement, head of the hard drive movement. By head of the hard drive moving up and then moving down and moving up and moving down. It's moved to cycle, to cycle, to cycle. That is a lot of movement. And here is the shortest service time first. It's moved only one circle. And about the scan move back to the front. Yeah, in this is wrong word. Over the hard disk. Maybe it is make the algorithm like as the elevator algorithm. When you use the elevator is moving down and moving up to read and write the data, so here this is the C scan. Now the scan, now the C scan. So C scan that use the circular scan, by read and write, in the same same situation. By here in this, read or write when the hard disk moving up. Here in this moving up. When it's moving down, it's not do anything. For this is called the C scan. This is a relate about the get the data or writing the data. So when the C scan will organize the number of the tag by check the circle for reading and writing. In is read or write by moving up. Here in this moving up the value. So in this picture is moving up and then is moving up. Not read and write in a part of moving down. And this is a C scan algorithm. When you buy a hard disk, the hard disk will implement algorithm inside the chip in the hard disk depend on type of the hard disk. Okay, now we will talk about in the third topics, that is RAID or RAID. What is the RAID? RAID is the redundant array of the independent disk. RAID is a physical disk drive that's built by the OS operating system organized the RAID. By the most of the system when you buy a computer, you not implement LED in your laptop and also in a general desktop that's used as only single hard drive. The LED used in the very large data storage and also some system that need to use the very high speed for data transfer and amongst very among offside the data transfer, very large data transfers. You make the LED system. The LED system used in the server and also high performance computer. The main function of the LED that is the speed and also the second that is the redundant or durable storage. That means when some hard drive is fault or bad sector or error in the hard drive cannot read and write, your data will remaining and you can recovery the data back to the system. That means when you implement RAID or RAID, your system not you don't lost the data when a hard drive in system is lost. From the slide, I show you only the 7 LED type by LED level 0 is no LED and LED level 1 to 6 is LED implementation. Here in this is a general LED implementation in most system. Okay, now we will look at the first. This is a no LED level. No LED level. By no LED level, that means it's no redundant data. In this picture, I suppose my system have four hard disks. Four hard disks. This one, this two, this three, and this four. 1, 2, 3, and 4. I have a data that have maybe I divided in 1, 2, 3, 4, 5, 6. This is very large data. I have a 6 part of their data. And I write the all of this data to the LED 0. By the LED 0 will split my work to write in each hard drive. By the first part of the data will write into the first disk, and the second part of the data will write into second disk. The third write in the third disk, and the fourth write in the fourth disk. So here in this, not redundant. That is no redundant data. But the advantage of the race level 0 is speed of reading and writing. So here your data split it into 6 parts to write to the 4 hard disk. That means example here in this like in 100 megabyte per second, and here in this write in 100 megabyte per second, and here write in 100 megabyte per second. Totally speed writing here up to 400 megabyte per second for writing. In the other way, when you're reading back, the data will reading back maybe over example. I suppose it is a 200 megabyte per second. That will get 200 to multiply with 4. This is maybe 8 100 megabyte per second for reading the data. The main point for work in the level 0 is its speed. Some people need very high speed for rendering the video for video editing. The server that need a speed for data access that implement level 0. But you should remember, if you lost a disk in this system, example, I lost this drive by error malfunction, you cannot access any location in the any data in the hard drive, you will lose all of this data, because this part is error and also this part is error. You cannot get information from the system in level 0. That is disadvantage of the level 0. Probability of this fail in level 0. When you have only one disk, its probability is 1. And when you have two disks in level 0, the probability is increased. That means you have two increase from this. This is 2. And here when you have 3 disks in level 0, increase in 3. That means the probability of hard disk fail in increasing by the number of the hard disk in the system. The advantage of the level 0 is its high data transfer capacity. This is a good advantage. For the disadvantage in the level 0 is high probability of failures. When the hard disk lost, totally your system will lose the data. From the disadvantage of level 0, and some system is remaining the data redundance, that is the rate represent rate level 1. The rate level 1 doing like as the rate level 0, but the rate level 1 use a lot of the hard drive. By here in this, we have 1 hard drive, 2 hard drives, 3, 4, 5, 6, 7, and 8. Look at this. The data from strip 0 is the same as the strip 0 in drive 5. That means drive 1 and drive 5 is the same. So here in this advantage is cost, very high cost. Also here in this you have a redundant function, but very high cost. Example, you buy in this hard drive about the 5,000 baht. Here in this, in each hard drive you buy it is in 5,000 baht. Here in this 5,000 multiply 8, this is 40,000 baht for making in this system. The next level of the rate, that is rate level 2. The rate level 2 try to reduce number of the hard drive by split the data from the that is we call strip. Strip is a large part of the data. Strip is a large part of the data. That means, example, I have a video file. A video file will will split into the strip that is a large part, a large part, maybe 10 megabyte, 10 megabyte, 100 megabyte is the large part for in each part in the file in your from your file. For REST level 2, the REST level 2 use the parallel access techniques by the data stripping is remaining used, but in this used by implement the Hamming code. What is the Hamming code? The Hamming code is the code that calculate by the like as the parity bit that's that is that make a bit for calculate the relation from the data. That means this is a main data, but this is the data from Hamming cost. The example when I have a data file, a data file, the data file will split into strip and right here, and all of this data will send to the Hamming code. The Hamming code will write the algorithm output to the hard drive. When your hard drive error, example, my disk is error, unable to read, the Hamming code will get the data back by make from all of this to return doing the function like as this hard drive remaining. So here in this is a concept of level 2. But the strip strip and number of the hard drive uh, and number of the hard drive is reduced from the level 1, but the strip size is over. It is the same size from the level 1. Now the level 3. The level 3 implement by without using the Hamming code because the Hamming code have a 3 hard drive for making the bit for remaining the data. The level T use the parity bit check and change from strip to be a very small by the look at the bit level. From the strip is a very large size, the strip will cut it into bit level, and the bit sequence right into the hard drive and use the parity bit check from the bit. Keep the parity bit to a hard disk. That's the same the output when you lost the hard drive. The parity can the restore or recovering the data from here back to the system. That is level 3. Now level 4. The level 4 is changing from the level T because the level T used in the bit level, but the level 4 used in the block level. The block level creates from the a sequence of bit. So here this is from the size strip it is very large and block and very small is level of bit. In late level 4, use the block by the use the same concept from the late level 3, making a block parity. Here in this a block parity to for keeping the data but keep in the block levels. Now the late level 5. Late level 5 use the technique from the parity, but here in this parity keep in only one hard disk, but in function for reading the data, the maybe the hard disk and parity will doing in the hard work for read and write parity check. So that means in this number 5 is read or write a lot of the process or a lot of work when compared from the 1, 2, 3 or 4. So here in this late level 5 used in the round robin method by distribute the parity bit to each drive. Here in this, in the box 0, box 1, box 2, box 3. Write the parity from box 0 to 3 at the fifth drive. And here box 4, 5, 6, and box 7. Parity from box 4 to 7. Write in the fourth drive. And block 8, 9, 10, and 11. Parity at block 8 to 11 right at the third die like this. So in this is a distribute the load for the hard drive from this the load at the fifth drive that is distributed to the each drive that is same loading from at this system. So here when I lost this drive, all of drive will be used to the recovery data to each drive. The next that is level 6. The level 6 use two different parity calculation, and two parity calculation provide extremely high data availabilities. That's also right parity algorithm 1 and parity algorithm 2 right into parity calculation for here for making the high data variability. Here in this is about we talk about the rate from zero. Rate zero is no rate. Rate 1 have a lot of the hard disk and relate about the high cost. Rate 2 use the Hamming cost. The Hamming cost have a problem about using 3 hard drive minimum. And the rate level 3 used in the apply in bit level. The bit level is very small. Some data need to write in the box characteristic of the box to reading and writing effective. So here this is relate about the level of the bit. And rate level 4 use the block and remaining use the parity. Level 5 distribute the parity. Distribute the parity to each die. And level 6 use two level parity bit. Okay, now we will talk about to the last slide, that is this cache. This cache, after you learn about the detail in this cache, you can implement this cache in any problem. By example, you can implement the concept of this cache to the software for remaining the data, for keep the history of the data access. Now the disk cache is a memory buffer between the main memory and disk. The disk cache this is contain copy some sector on the disk. And also you can use in the technique of this cache to making the data transfer or keep the list of the data remaining in your system. By technique of the disk cache divided into type, that is least recently used and least frequently used. Okay, now from the left, that is the least recently used, and the right, that least frequently used. At the least recently used, this is a sequence, this is a memory, and here this is time. By start at the hard disk is empty. No. Memory is empty. This is empty. No data in the memory. Now the data letter A to the memory. A right to here. And then B is come follow A. B right here. A moving down. And C come here. C right to memory. And they're moving down until F. During F coming, the memory is full. The memory is full. The eliminate is meaning it moving out. The moving out is a reset that's implemented by recently used. That means A is used by first. This is long time for keeping in the memory. So here in this, F is live and A is moving out from the memory. That means A deleted. And then it's use C again. It's being C to use in some work. And then C writing back. C will write at the last of the list in the memory. Here in this is the main point. And then G come G write to the disk to the memory, and B will eliminate from the memories. Here in this point is a list recently used. When you use example, when I use here, use F. So the list will change by F will be here. This is technique of list recently used. And the right, that is list frequently used. The list frequently used have a data, memory data, and also counter. Here in this counter, frequency counter. Here in this, the memory have A, B, C, D, E. A used in the 32 time, and B used the 30 time, and C used the 26 times. Now the data D is bring to use to processing in the system. The B will increase from 26 to be 27. Now B apply B increase from 30 to the 31. That mean in this from this list, A is used a lot of frequency and E used a few frequency. So here the new data F coming, that is E is will eliminate because E is this low frequently used, and A is very high frequently used. You can use in this technique to implement in the algorithm for keeping list of the data in a small memory. But also you can use less recently used and least frequently used. Okay, now I will conclude. Here in this chapter, I think you understand about the buffer, and also you understand about the data access by the hard disk. That's first in, first out, shortest service time first, scan and C-scan. And I think you can explain the type of RAID or RAID, and also you know about the disk. Now, here in this chapter, now we will study to the end this slide from this subject. And if you have about the detail in this, you can in this class you can begin to implement writing the computer code and make the code. I know you don't have experience to writing the computer programming in C language, but if you use in the example code here in this, you can bring my example code to study how to write the code in C language and improve your experience in the future. Okay, now in this card, I will close this card and see you again in next class in future. Thank you and bye bye.